3.3, the addition rule, mutually exclusive events. So in 3.2, we covered the multiplication rule, and that was dealing with the word and. So and is the multiplication rule. Now we're going to see the word or. And I'll explain the difference between the two once we um, get into this lesson. All right, mutually exclusive events. So two events A and B cannot occur at the same time. That's mutually exclusive. So I think about it like relationships. When you're in a mutually exclusive relationship, there's no one else. It's just you two. Okay. So A and B have no common outcomes, and this is what it looks like as a graph. Then mutually exclusive, not mutually exclusive, excuse me, is when there is something overlapping, something happening at the same time. Something overlapping or happening at the same time. Not bad. It's just that, we have to consider, okay, this thing is showing up twice in our data set, or this person is showing up twice when we actually go through and look at all of the possibilities. So let's look at some examples. Determine whether the events are mutually exclusive and explain your reasoning. So event A, roll a 3 on a die. Event B, roll a 3 on roll a 4 on a die. So when we're talking about mutually exclusive events, we're only doing one thing. So with the the multiplication rule, we were doing one thing and then the one thing and then the one thing and then one. So we kept doing more than one thing. We were picking more than one thing. When we're talking about the addition rule, we only have one pick, and we're trying to see if this one pick is like doubling. Is it doing two jobs? So if I roll a die once, can I get a 3 and a 4 at the same time? Can I get a 3 and a 4 at the same time? No. So because I can't, these are mutually exclusive. It's going to be a little backwards of what you would think. So mutually exclusive means there's nothing in common. Mutually exclusive means there's nothing in common. Let's look at the second one. Event A, randomly selecting a male student, randomly selecting a nursing major. So can I pick a student who is a male and is also a nursing major? Yes, correct. So because I can have both at the same time, this is not mutually exclusive. I can pick a male nursing student. Here, I can't roll a 3 and a 4 at the same time on the same die. Okay, last one. Randomly selecting a blood donor with type O blood. Randomly selecting a female blood donor. So I'm randomly selecting one person. Can this one person be type O and female? Can it be type O and female? Correct. So yes, both can happen at the same time, which means they're not mutually exclusive. I'll say it one more time. So both can happen at the same time, which means they're not mutually exclusive. I know it's going to take some time to wrap your head around, but we got this. So both can happen at the same time, so they're not mutually exclusive. Alright, so let's talk about the addition rule. So how does this work when we're actually working our problems? So the addition rule for the probability of A or B. So now or means we're going to be adding. Or means we're going to be adding. So we're going to add all of our probabilities together when we have mutually exclusive events. But when it's not mutually exclusive, so this is mutually exclusive events, we're just going to keep adding them. When it's not mutually exclusive, we're going to add, but we have to take out the part that intersects, the part that overlaps. Okay, let's look at what that's going to look like mathematically. So you select a card from a standard deck. Remember, we're only doing one thing. This is one thing. Find a probability that the card is a 4 or an ace. A 4 or an ace. So first, if I pick one card, can it be a 4 and an ace at the same time? No. Good. So that means that these are mutually exclusive. So that means I'm just going to be adding my probabilities. So I'm going to break this first one down. Probability of 4 in a standard deck of cards. 4 out of 52. If you need me to send you a deck of cards, let me know. I'll print something. Well, I have something already saved. I can just send it to you if you want me to send it. But Googling will do the trick. Alright, so 4. And then there are 4 4s in the deck. And the aces. There are 4 aces in a deck. So we're just going to add those two together. 4 or ace. Normally I do the PE thing, but I just wanted you to see. This is how we're putting this together. So 4 over 52 plus 4 over 52. If you wanted to show your fraction skills, you can, but I'm just going to put it in the calculator. Make sure the glare is gone. And that's our decimal. Remember, we want 3 decimals just in general. If they want you to do more, they'll show you more. But 3 decimals normally will do the trick. This is 0.153. That 8 makes that 3 go up to a 4. So 0.154. Now, if you want it to be fancy and get the fraction, because you just want to know what it is, this math button, math enter, will turn it into a fraction for you. I'll show you. Math enter. It'll turn to a fraction for you. But you really don't need that. We just want the decimal overall. Alright, so let's look at an event that is not mutually exclusive. And I'll probably throw in an extra problem since I have space down here. Alright, you roll a die. Find a probability of rolling a number less than 3 or rolling an odd number. Less than 3 or rolling an odd number. So I am going to write my sample space here for a die, because it's going to be easier for me to break it down. This is a standard die. So rolling a number less than 3. So what are my possibilities? Less than 3. I have 1 and 2. So I'm just going to put less than 3. So we'll know what that is. So there are 2 numbers for that. So less than 3. There are only 2 numbers. That's why we have that. I'm not going to reduce this. I'm not going to reduce it, because I'm in the middle of my problem and I just want to keep it nice and easy and clean. There's my OR, so I know I'm going to be adding. Rolling an odd number. Rolling an odd number. So how many odd numbers do we have when we are rolling a 6-sided die? Just 3. The 1, the 3, and the 5. So those are 3 numbers. But how many numbers did we have in common? How many numbers did we have in common? So for less than 3, it was 1 and 2. For odd, it was 1, 3, and 5. So we had one number that we had in common. One number that we had in common. So there was one number that was less than 3 and odd. So we're not looking at the number 1. We're looking at how many numbers do we have in common. And we only had one number in common. And that's why we have that 1. So we'll go back over that one more time. So numbers less than 3, we counted. It was only 1 and 2. Over here. Odd numbers. it was 1, 3, and 5. But when I look at all the numbers that I have that fit those characteristics, there's one that shows up double. So I can't count it twice because it's actually um, it's important. I need it. It's just showing up twice. And so that's why we're only going to take it out one time. Okay, we're only going to take it out that once. So here is the fraction or problem. The less than, the odd, and then we take out however many we have overlapped. The less than, the odd, and then the less than and odd. So you can, again, do all of that on your own and subtract and all that good stuff. I'm going to let the calculator do the work for me. So 2 over 2 6 plus 3 6 minus 1 6. It is repeating decimal, but we want to keep it in decimal form. So we're going to round it. Okay. I did want to do another one of these just to make sure you're good. So let's do roll an odd or less than 5. So it's our extra problem. Roll an odd or less than 5. So odd we already know. We did that one before. Odd. That was the 3 over 6. Had a brain freeze. Less than 5. Think about it. Go up to the top if you need to. How many numbers are less than 5? It didn't say 5 or less. So 5 isn't included because less than 5 is 1, 2, 3, 4. Alright, so now let's think about how many numbers are less than 5 and odd. How many numbers are less than 5 and odd? So if you need to write them out, I'm going to write them out down here so we can kind of see. Odd, less than 5. This time we have two numbers. We have the number 3 and the number 1. So we have two numbers this time. 1 and 3. You don't have to write it out this long like I'm doing it now. This is just for, teaching purposes. Odd and less than 5, we said there was two numbers that fit that. The 1 and the 3. So I'm not putting 3, I'm not putting 1. I'm going to put how many fit that characteristic. So while I'm writing this, see if you can get that answer in decimal form. Plus, let me take away the 2. Yep, 0.833. So here's the gist behind it, just in case you want to know, well, I don't understand. Okay, so we're looking at all the numbers that we have all together, and we're taking out the double. So if I were to do this problem math-wise, this is going to be 3 plus 4 is 7 minus 2 is 5. So I should have 5 numbers that are odd and less than 5. But when I do this, I have 1, 3, 5, 1, 2, 3, 4. That's 7 numbers all together. But I don't have 7 numbers in my actual possibilities. So I have too many numbers. 1, 2, 3, 4, 5, 6, 7. And my bottom numbers are 6. Something's not right. So that means I have some doubles in there. I need to take it out. So the 1, that's one possibility. It makes it 6 over 6. And then the 3, that makes it 5 over 6. So I'm taking out the numbers that show up too many times. That's pretty much why I'm doing what I'm doing. Alright, so let's look at it in the aspect of a chart. A blood bank catalogs the types of blood, including whether it is Rh positive or Rh negative, given by donors during the first 5 days. The number of donors who gave each blood type is shown in the table. Okay, so I'm just going to, I may have to bring this up a little bit, so I'm going to write these so we can see them, whether, I shift my paper or not. Alright, find the probability the donor has type O or type A blood. So we'll know if something is not mutually exclusive if our numbers will crisscross, or if there's an intersection, pretty much. So can you have type O and type A blood? No. So those are mutually exclusive. So when I look at my chart, I see that they do not intersect. Alright, so type O or A. This does not have the word given in it, so I'm going to just use my total and use the totals that are given. So type A is 164. Which one? Oh, let's do O first, because it was first. O is 184. And they get that number from adding those two numbers together. And then type A is 164. And notice I'm using the total this time. It didn't have the word given in it, so I can use that total. Didn't have the word given, so I can use that total. So let me give you a minute to put that in the calculator to figure out what that number is. And you should have gotten 0.851. 0.851. So you cannot be O and A at the same time. And we can see that mathematically. Let's look at the next. Find the probability the donor has B or Rh negative. B or Rh negative. So can you be B negative? So because we can, that means it has an intersection. And we're going to subtract that intersection. Alright, so let's look at what that looks like. So B is 45. Rh negative is 65. Rh negative is 65. Now, where do they crisscross? Where do they intersect? They intersect at 8. So to get 65, 28 plus 25 plus 8 plus 4, and to get B, 37 and 8, so that 8 showed up twice. And so that's why we have to take it out just one time. Make sure everybody's good with that. So we added to get the 65, we added to get the 45, but we ended up adding the same 8 people that were RH negative, they showed up in the B. So we had to take them out just once. That's why we only take them out once. So what's that answer? 0.249. Good. Good, good, good. All right, find a probability the donor does not have type O or A. Does not have type O, type A. So if they don't have type O, type A, what are we talking about? If they don't have type O, type A, what are we talking about? We're actually talking about B and AB. Good. So not type O, not type A, B and AB. So maybe I need to write that. Let me put that. Not O or A equals B or AB. Good. So B is 45 over 409. AB is 16. They did not intersect because we're looking at a not type, so it's not going to intersect when it's a not. Okay, and what does that give us? Mm-hmm. 0.149. Good, 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 good. 0.149. Now, those people who are able to see complements really quickly, you probably picked up. I didn't get it at first. It took me a couple of times doing this. But you probably picked up that we already had O or A. O or A. So what they're pretty much saying is not what it is in number one. So it's the opposite of one. So we could have, can't see that. We could have subtracted the answer for A. And gotten that. I didn't see it. Promise you, I didn't see it. So if you didn't see it, no worries. We're all in the same boat. So remember, sometimes you can just use, okay, you're saying you don't want this, let me eliminate this and then add what you want. That's what that is. Or you can look to see what you already have, and if you already have what they're saying they don't want, to complement. Alright? Again, don't panic if you didn't get it. I didn't get it either, but it is the easier way to get your answer.